So this question is from WebAssign 10E, I believe it is. I don't remember what number though, I'm not gonna lie to you. But this is what it looks like in the circuit below, in the circuit in the figure below. Determine the following. Very straightforward directions here. So we have our full circuit here. I just labeled, so loop 1 is right here, loop 2 is right here, and loop 3 is right here. And the full circuit is what I considered loop 4, which you'll see what I did like down there. So there are 3 different batteries, by the way, can I just say. And so I just drew kind of like the flow, and then I tried to label so you would like know what loop I was referring to when I was doing the math down there. So we have the flow of all of these, because bam, and then the overall flow is going to be zwap. So yeah, let's get started. Part A, the current in each resistor, find the current in each resistor, indicate the direction of the current flow through each resistor through the sign of your answer. Take upward current flow as positive. So I just wrote down the junction rule says the current in equals the current out, and then the loop rule says that the change in V equals 0. So loop 1, I actually didn't label it with the numbers. I'm so sorry. In loop 1, I have 80 volts minus 360 volts minus 20 ohms times current 2 minus 70 ohms times current 1 equals 0. And I'll show you exactly how I got that. So loop 1, like I said, it was this right here. So if we're starting from here, here is where we get that 80 volts, right? 80 volts here. And then when we go down, we're hitting that 360 volts. In this case, that because you're going from positive minus right there, so it's minus 360, minus 20 ohms here, and that's right when we hit resistor number. I'm calling this resistor number 2, but our 20 ohm resistor, and that's also going to be right where our current is. And so that's how we got, hello. And that's how we got minus 20 ohms times the current 2. And then it's going to be minus 70 ohms right there, current 1. So that is our equation for loop 1. Loop 2 now, I'm just going to tell you this. So loop 2 right here, we're going to start right from here. So 360 volts minus 20 ohms times current 2, and then we go zwap, and we're going to hit that minus 80 ohms times current 3, plus 40 ohms, or I'm sorry, yeah, plus 40 volts, because we're following the correct flow. When we turn there, it's going to be positive to negative, so we're going to add it. And so that's how we got this equation right here. Oh, also equals 0, loop rule, remember. And these are all loops. I thought I did these in cursive. Anyway, so loop 3, we're going to move on to loop 3 now. Loop 3, we're going to start from here. 40 volts minus 200 ohms times current 4 minus 80 ohms times current 3. Bam, equals 0. Full circle, and there we see it right here, minus, minus, all that fun stuff. And now loop 4, like I said, that's going to be our full circuit. This did confuse me a little. I don't know if I can talk about it. Well, I don't know. I will talk about it now. So, like I said, it's the overall, so we can kind of ignore everything in the middle here right now. All those different batteries, because we just care about this one. So, 80 volts. 200 ohms, so minus 200 ohms times I4, minus 70 ohms times current 1. We go back to there, so equals 0. Wow! And now for our junction equation, I did, remember, in equals I out. So I1 plus I2 minus I1 plus I3 minus I2 minus I4 equals 0. And I'll explain why what's positive is positive and what's negative is negative. So we can see that the way this flows, right? So I1 is up, is flowing upward. And remember, take the upward current flow as positive. So upward flow current, positive. Upward flow current, positive. And that's at I3 and I1, right? And then I2 and I4, that's downward flow, downward. So that's going to be negative. And that's how we got this great equation. I plugged that into my calculator. I got I equals 4, I2 equals 8, I3 equals 3, and I4 equals -1, which means that it is in the negative direction, or the negative current flow, like through each resistor. Sorry. And then part B, the potential difference across the 200 ohm resistor. So here's our 200 ohm resistor, right? And now we need to know, we're going to use the equation V equals IR. So the I is what we just figured out right there. So it's going to be positive though, because this is scalar. I hope that's correct. Yeah, it's scalar. So either way, this is gonna be a positive, and then times that 200 ohms, which is just a resistor, and so V will equal 200. So that's gonna be what the potential difference is. The reason why this confused me so much was because, well, at first I honestly didn't understand the flow, because I thought when you, from the positive, you would hit here and suddenly it would turn negative, and it'd be like, do I go this way? Do I go that way? So that's where I got confused at first, but I figured that out. And then, okay, just like the sheer amount of loops this was kind of a lot. And I honestly didn't know how to set these up at first, but then I figured it out, because I'm a genius. No, not actually. But I had trouble doing that at first too. So once I figured all that out, I was like, oh, okay, perfect. And then I was like, now what the freaking what the heck is this here for? But it helped with the direction of all these, and when we did the system, helped with all this up here. So that was confusing, and then, I mean, this was simple, V equals IR. I did have this negative at first, and I was like, because I didn't understand why it was positive. But yeah,